Hi guys, welcome to another studio workshop from HOFA-College. Just in case that you don't know us, who is HOFA-College? We are an online academy and we teach you audio engineering. You can do a diploma or even a bachelor in audio engineering with us. And today we are going to talk about analyzers, spectrum analyzers, frequencies analyzers, and how you can use them to get better recordings, mixes, masters, or for your sound design. So just another explanation before we start with the actual workshop. We have a department that develops audio software and plugins, and we have with HOFA plugins a spectrum analyzer in our programs. That's the IQ series analyzer. And just for a few days, because of this workshop, you can get it as in a flash sale with a 20% discount. Just go to hofa-plugins.com and when you order it, type in Analyzer 20 and you get that discount. So far for that. What is an analyzer for? It shows frequencies, of course, and how it does that, I want to show you now. All right, I have prepared a project, of course, like always in Cubase, but you can, of course, use this analyzer in any DAW. And that is the first point. How do you use it in your DAW? I usually insert it as an insert, the plugin as an insert in my control room of Cubase, that's here. And then it is available in the stereo out of every project. And I don't have to do it for every new project, insert it as a new analyzer. So it's always there when I need it. And I don't have to insert it in every new mixer that I need in a new project. So what does an analyzer show? It shows frequencies. It has two axes, one from the left to the right, the horizontal or x-axis, that's for the frequencies. It shows a frequency range from 20 to 20,000 hertz, 20 hertz to 20 kilohertz. And it shows the level in dB, of course. And just to explain it in a practical way, a low note is farther to the left, and a high note is farther to the right, of course. And you can see a louder note that is louder played has a higher level here in the display. So that's pretty easy, of course. And I can show you further uses than just showing frequencies and notes. But the interesting thing about this, our analyzer, since it is a filter bank analyzer, it has 121 bands. That is exactly the range of semitones in the range of 20 to 20,000 hertz. So you can see every half tone, every semitone on the analyzer. You can see every note, every seminote is a new frequency on the analyzer. That's of course, a good thing to show you notes, but of course it's the normal use for analyzers is to analyze sounds and not just which note am I playing, but where are the frequencies of the sound I am using. And that is used, for example, when you're recording, when you're placing mics and you want to see where is the best sound, where do I have the best fundamental tones and the nice overtones, the nice harmonics of the snare, for example, or where do I get the fundamental tone range of the bass drum or a bass guitar in the best possible way, and so on. And that's the stuff I want to show you today. And first we have to understand how an analyzer displays the frequencies. We can yeah, we can distinguish two main forms of displaying the frequencies. You can show it in a technical correct way or in a way that syncs with the way human beings hear music and hear frequencies. And most or every human being hears high mid-range frequencies louder than low frequencies. So a loud note needs more energy to be heard with the same loudness than a high note. So we in our analyzer have a way to adapt to this human hearing, and that's the so-called slope. You can set this slope in in this window with a dB per octave slopes. That it means the display gets quieter with every octave by 3 dB, and I can show you that with pink noise. And for that, I have the following test tone or test noise. And since this is really annoying, I just turn it down. We only see it. Don't worry, we will hear some nicer sounds than that in the workshop, of course. All right, yeah, this is pink noise. But if you look at the test generator, you can see in the display a pink noise is displayed as a falling curve. And this is the technical way to describe pink noise. Every frequencies in this noise is not technical, but audibly on the same level. So low and mid and high frequencies are heard as with the same loudness, but they are technically not the same level. And if you switch with the slope to 0, you can see the pink noise. It is viewed or seen by a technical meter, but in fact, for our hearing, it sounds like this. So this is something I would really use in the normal working with the analyzer in a mix, because this is the way I hear it, and it comes on my loudspeakers, and it really matches with what I hear. So I really prefer this way of displaying the frequencies. So, and a analyzer can be a little bit more than just a display for frequencies. It can also show you, of course, levels and meters, and it can also show you a stereo display. And I want to start with that. So let me put the level back on 0 dB, so we hear something. I recorded just a little track with the Rhodes I just played here. Oh, sorry, turn it off, the other stuff. Okay, you can see what you heard, and that's typical for a Rhodes. It's a little bit mid-heavy, so the range around the fundamental range is a little bit louder than the overtones and the harmonies and the high notes, and that's typical. But you can also see that it's a mono signal, because here there is a so-called goniometer, which is also showed by the IQ series analyzer, and it shows you that it's like that. It's a mono signal. And you can also see that every signal from the frequencies is mono as well. It's not only the stereo sum that is mono, but every range, every frequency range is mono. There's no going wider. But if you make it stereo, it can show you this too. I put a chorus on it just for turning a mono signal into a stereo signal. Now you can see that there is stereo information. There are here is shown the width of the stereo, and this goniometer is displaying the levels on different different levels of the display, and this signal here in the goniometer is a mid signal. On the other side, on the lower side, is a side signal, and there's a left and the right channel. And the goniometer is showing this, as a kreis, a circle. So look at this, and you can see what's happening. There is energy in the mid, but also downwards to the side and on the left, on the right channel. I want to talk later about mid and side and left and right channel, but just to show you that this analyzer is also showing you the stereo image and the stereo width of the whole frequency ranges. Just look at this field again, please, here. And you can see what a chorus is doing. It's moving between left and right, and it's doing this with the circle a certain speed. And if I turn up or use a different speed, it sounds differently. Or if I make it wider, it gets too wide, and it shows you that with red frequencies. Okay, just another feature showing stereo width and the width of some frequency ranges. All right, so we have frequencies, we have the loudness or the level, to be exact, the volume of frequencies. We have the stereo width of frequencies, and we can use this to understand the sound, to understand if it's balanced or not, if there are certain resonances. I want to show you this with another track, and this is a vocal track. And you can just analyze it. Just a small a small vocal line just to fill in, just to show you the frequencies of a vocal range. We have two different things on the display of the analyzer. It's fundamental range and the overtone range. And here, this is, it's played in E, in A, sorry. Huh? Okay, these are the notes, and you can see that the range around here, 700 to 800 hertz, is pretty loud. And on the other hand, you can also hear that there's a lot of air in this recording. There is a lot of hiss almost in the high frequencies, and that is this range. So there are probably two things we can learn from this display, from this image on the frequency analyzers, that maybe there's something to do about this resonance at, let's say it's a resonance around 800 hertz, but it's a fundamental tone, of course. You can check this with the keyboard here. It's exactly at 880 Hertz. And you can use this frequency to correct it with an equalizer. Let's just do it with the EQ for a second. Okay, Tanmay is asking what the fundamental frequency for the vocal is, depending very much on the range. This is a rather high sung female vocal that is much higher than a deep male vocal, for example. And the fundamental tone range from human voices is from something around 100 Hertz to maybe 2 or 3 octaves higher, or even more. Some voices have a range of 4 octaves, and that can range from 100 something to like a kilohertz or even more. And what is a peak? Around 600 Hertz, before 800 Hertz. Yeah, just that's probably something I played, but you can also listen again. And in an ideal case, this visual display of the analyzer matches with what you hear when you have a good headphones or good loudspeakers in your room. And you can hear that this frequency is a little bit louder when the singer, sings this note. This is probably a G. Right, and the next one is the higher one is the C. So the A, the resonance or the fundamental tone of the A is a little bit louder than the fundamental tone of the C. Not because she's singing it louder, but because it's the voice and the mic and the recording is a little bit resonant here. So we can work on this frequency with the equalizer and make it a little bit quieter with a rather narrow Q factor. Even a little bit more. And maybe even use a little dynamic reduction. Okay, and now this frequency has the same level. That's even a little bit quieter. Okay, so just as a fast step for a better sound, it has not to be exactly like that, but we can just compare maybe the work without equalizer. And make a snapshot and then work with the EQ. Okay, so we can see I reduced a little bit too much. That's taken a bit too much out of the frequency range, so I reduce the reduction. Do it again. Okay, and now it's getting more balanced. And that's just the way we can use the display, what we see on the display, what the frequency analyzer is analyzing. And if we hear it as well, we can make decisions for our EQing. And that's a really helpful tool, especially if you are working in a not perfect surrounding with with loudspeakers in a room which is not perfectly optimized, or with a headphone somewhere when you're working in the train and you still want to do some vocal edits. And yeah, you can use the analyzer to show you what is maybe wrong with the signal, or what are the characteristics of a certain recording. And you can use this to make clearer and faster decisions with when mixing. All right, so okay, let's say this is for the vocals. I also wanted to show you a thing where an analyzer can show you differences between sounds very clearly. And when you compare sounds, for example, when you're looking for a nice drum sound, a nice snare drum for your next drum programming, and you're not sure which sounds better, an analyzer can help you to explain why a sound sounds like it sounds. And I just put 3 different snares in a instrument. It's the virtual drummer, studio drummer from, come on, here, from Native Instruments. Okay, and this is one sound. Come on, move. I want to make a loop, so all right. And I'm just make a snapshot, and this is what the snapshot looks like. And you can switch between 3 different snare sounds. And this is another one. Just comparing these 2 sounds makes clear why they sound so different. We again have a fundamental tone and some harmonics, some overtones, and a very wide range of harmonics and overtones, and even a noisy aspect of the snare drum. And this explains why those 2 snares sound so different, even as they have the almost same fundamental tone, around 200 hertz. The overtone range is completely different, and this range is much louder in the one snare, in the one we heard first, and the other one that we heard second has a louder fundamental range, fundamental tone, and so they sound different. This is this one, and the other one sounded like this. And the third one even sounds different again. So we can see it has a much higher fundamental tone. This is like around a B, and the other ones were around a E, and the lower one even a semitone deeper. And yeah, you can see this is like 4 half notes, half tones, and that's quite a difference. And these informations can help you to find out which one sounds better in my song and why do I like it better. Do I like the one with more overtones, or do I like better the stronger fundamental tone? And that's a good way to find out where your preferences are and what do you like and what sounds fits to the song you're working on, and that can help you for the next time to make faster decisions and to find out what your preferred snare drum sound is. And you can use the analyzer to get to faster decisions for a sound, even when you make some sound design when you're working on drum sounds, maybe with a synthesizer or stuff like that. Okay, so we talked about the frequencies and the axis. We talked about the slope. We talked about the goniometer and the correlation. And I always showed you that you can make some snapshots. Snapshots with the analyzer, and you can compare those snapshots. But a great feature and a great help in understanding what's happening in your with your recordings or with your files is to just take them and to drag and drop them in in your in the display, and that is working with almost any DAW. Unfortunately, not with Pro Tools, but it's working with Cubase, Studio One, FL Studio, Ableton Live, Logic, and you can use it to analyze those files, those clips, and without actually playing them in real time. And that's much faster, especially when you're comparing mixes or masters. And that brings me to the next project. I want to show you really what you can do in an actual mix, and not just as an explanation of different sounds. One thing I have not yet mentioned, a really important feature of the IQ series analyzer is the differentiation, what a word, between the peak hold line and the energy curve. That's what we call it. When you look at the vocal clip here, you can see two curves. The one on top, the higher one, is these are the peak levels, and the lower line, the lower curve, is for the energy. And that is something like that is shown when you measure the whole clip with a RMS level, which is with a slower metering, and the peaks and the peak hold curve only shows the loudest frequencies and the loudest volumes of those frequencies of the measured clip. So sometimes it is really interesting to see what the loudest parts of a frequencies are, but it's also equally important to see the frequency of the frequency information over the whole song. For example, let's take a drum sound, and the drummer plays a very loud crash one time in the song. This crash is displayed as a really loud high frequency event, and if you think this is my frequency curve and you turn down these high frequencies, your whole mix gets sounds muffled, and it doesn't help anything. And that's what the energy curve is for. In the energy curves, you see that this one-time event of a loud crash is not really relevant for the whole mix, and I can show you that in a later example. So let me just close this project and open the next project. I see that there are some discussions in the live chat. Cool. And there's a question about slope curve for analyzer 4.5, or I like 3 dBs per octave because it's pretty much what I hear is what I see, and it matches with the my visual information matches my auditive information, and that's why I like 3 dB per octave as a slope. All right. Next project, and while I'm doing that, just let me do this. let me just remind you of the flash sale that is available just for a few days, and you can save some 20%, no, exactly 20% on the analyzer. So, yeah, let's get practical. This is a really nice way to use it in a mix. In the project before, I have said that I am using the analyzer in the control room, but sometimes it can really be interesting to have the analyzer in single tracks or groups in your mix to see where the frequencies of certain sounds are and how you can level them and go for a balanced sound. And that's especially useful, let's call it, for bass management and to check out the balance of different instruments in the bass range. And that is really useful when you're balancing and leveling bass drum, bass guitar, and snare, or doesn't have to be a bass guitar. In this case, it's a bass guitar, but it also can be electronic or synth bass, sure. So let me just show you this. There are 3 extra analyzer in this song. They are one in the kick drum group, one in the snare drum group, and one in the bass track or channel. And each of these 3 analyzers can be shown in the list of this of our main display, and I can see them at the same time. Just let me demonstrate this. Okay, that's it. So you can see there are 3 different curves and 3 different colors, and I matched the colors of the project with the colors in the analyzer. In this case, when you're just listening to a short loop and there's nothing extraordinary and dynamic happening and no loud crashes and no resonances, then I usually turn off the energy and the RMS metering just for the sake of clarity and for a more for a better overview. So you can see the green one is a bass drum, and the pink is a snare. So 3 of them are selected. So okay, now it's just bass drum and snare, and you can see the bass drum, the fundamental range of the bass drum and the snare are on a not exactly the same level, but close. And you can also see that the fundamental range of the bass drum is much wider than the fundamental range of the snare. So that's the reason why the snare needs to be a little bit louder in order to be heard with the same loudness. And the bass is exactly between the 2 of those. It's higher than the fundamental range of the bass drum, but it's with its fundamental range on its own, it's lower than the snare. So turn it on again. But of course, they overlap, and they have to. Do not do the mistake or make the mistake to try to, okay, the bass drum should be here, and I cut everything that's higher than the fundamental range, and the bass guitar should be between fundamental range of the bass drum and the one of the snare, and I cut everything below and above that fundamental range. that makes for a very transparent sound, but sounds like shit. So has to be overlapping, and it has to be some linking between the instruments, or else it sounds transparent but very technical and separated, and that's not a good sound. Every sound, no, not every, but a lot of sounds need harmonics, need overtones, need different levels of fundamental and overtone ranges, and it's really important that these ranges overlap, but they should not be exactly the same. For example, if the bass would play an octave lower, what would be extremely low, but just let me show you for a second. Come on. I need the infill line, right? It doesn't sound nice, but I transpose just the bass by an octave. That's not a realistic range, but just for showing you. Now, bass drum and bass guitar have the same range, but it doesn't sound good. It's just, you can't hear the bass clearly anymore, and the bass drum is a little bit blurred by the bass. So let's get back to the original level. Where's my... Why didn't I go back? Yeah, it did. Okay. Okay, and the interesting thing, that's another thing about working with analyzers, it tells you a lot about the sound of an instrument. When you look at the thing, the bass, or the line the bass is playing in the analyzer, you can see that the loudest range is somewhere between 100 and 200 hertz. But this is actually not the fundamental tone range. The fundamental range of the bass line starts on a G, and this is this one here. It's at 49 hertz. That is a rather low note, of course, and if the bass guitar wouldn't have such a loud overtone range, the first harmonic range is louder than the fundamental tone range, that's usual on bass guitars, then it wouldn't be so audible in the mix, and that's why the fundamental range of the bass drum and the first harmonic of the bass guitar match pretty much with each other, and they go well with each other, and they leave place for the low end of the bass drum and the audible range of the bass, and still the fundamental range of the snare drum is a little bit on top of that. And of course, that is something, this knowledge can be used in your mix to get a clear, a clear bass management, a clear, transparent low end. And of course, I used this knowledge for working when mixing the instrument and setting the bass and low mid frequencies of the bass guitar. So that's a way you can use those analyzer instances in one display and use it for different individual channels, but not for the overall mix. If you want to go for the overall mix, I want to show you another project, but I have to open that first. And in this project, I can also show you, just a second. I can also show you the difference between the energy and the peak curves. And just let me run that short excerpt I have prepared of that. So here it goes. All right. As you can see, there is the whole range of frequencies from the low end, starting at around 40 hertz, up to the high end, and it's always in the high frequencies getting a little bit quieter. There's a sort of roll-off in the high frequencies. And the mid-range is a little bit louder because there are a lot of vocals on that track, and the keyboards and the guitar are playing in the mid-range as well. So this is a little bit mid-heavier than, for example, a electronic dance track, whatever. So if I turn off the vocals, you can see that there will be, like a different picture. And you can see that there's a lot of space here between 1 and 4 kilohertz. That's the range where the vocals have their window. And just to make it clearer, I also inserted a analyzer in the playback group and a analyzer in the vocal group. And that's really helpful to understand where the frequencies of the different groups are, and to work with equalizers and set the levels accordingly to get that picture in the analyzer. You and me right on right, when your face is all I seem to follow. Right on right, when the time goes out. Right on right, when the world is here between you and me. Right on right. Okay, and you can see there's much more energy in that range. That exactly is quieter in the playback. There's only one instrument that is in the playback, but it's as strong in the fundamental range of the vocals as the vocals itself. And I want to show you that. This is the following instrument, the lead synth. And it's used as a support of the lead vocals, and it's adding something to the lead vocals, and it plays the same line as the lead vocals, but it's much stronger in its fundamental range than in the overtone range. When you add the lead vocal to that, you and me right on right, when your face is all I seem to follow. Right on right. You can see that the fundamental range of the lead synth is just about the same, has about the same level as the lead vocals, but still doesn't, it doesn't verdecken. Jesus, my vocabulary today. Still, the lead vocal track has enough power and energy to get in front of that lead synth. But if you turn off the lead synth, something's missing. And I want to do that as well. So where is it here? You and me right on right, when your face is all I seem to follow. Right on right, when the time goes out. Turn it on again. Right on right, when the world is here between you and me. Right on right on right on. So it just adds another character and another feeling to the sound of the whole arrangement. And that is where an analyzer can help you to make decisions about the EQing, but about the leveling of instruments and groups as well, to find out where is the fundamental range more important, where do I need the overtones, and where I do need more louder present range and higher frequencies. And if you know about that stuff, how much energy does a present range need to make a vocal stand out in the mix, then you can use the display of the analyzer to make decisions about the EQing and the leveling and the compression and all that stuff. And that's why I love working with analyzers above everything else you can say about analyzers. They won't get tired. They work in every room, whether it's a perfect control room or your living room or your office, whatever. It's always shows you the exact frequency range, whether you hear it on a small phone speaker or a loud control room speaker with 10-inch bass speakers. It's always the same. And that's why I love working with analyzers, and especially if you're not the everyday pro mixer who's working 10 hours a day since years and knows his speakers perfectly well, then you maybe can work not all the time with an analyzer. But still, I know a lot of professional mixing engineers who still work with their analyzer just because it's another tool that helps you create better mixes and masters. And it's really, it's really worth it. All right, this one for that mix. Let me show you another thing about it. And that's the one I wanted to show you, the importance of energy line versus the peak hold curves. In this part, there's the lead vocal track has a de-esser. Where is it? Here. That is the de-esser. I can show you how it's working. It is reducing loud sibilants, whatever, when they are too loud. And I can show you how it's working. Like time or goes out and all that S and T's and sh sounds, they are reduced when they are too loud. And just let me make a snapshot of this one. And now I turn the de-esser off. Okay, so you can see here the peak and the high frequency is louder, but in the energy curve there is almost no significant difference. And this is so important to know that this peak is just one or two loud S and sibilants, or it could be a crash as well. And it's not necessary to reduce the high frequencies in the whole mix, but it's better to use just a dynamic tool like a de-esser for that, and not a equalizer for this. So another way to understand the information the analyzer is giving you is to differentiate between the energy curve and the peak or the peak hold curve. Okay, that about this. I often use the analyzer also for comparing my mix to another mix. This can be another mix from the same album or from the same band or the same artist, but it can also be something like a reference mix. And you can save your own references if you want to, or you can use references that we put into the analyzer for various genres, from pop rock to electronic to vintage to big band to jazz, country, whatever. But you can also make your own reference mixes if you have some songs in some genres that you think they sound great. Use them as a reference mix, and you can use that both to check the frequencies, but you can also use it to check the dynamics and the loudness of a track. That's especially important if you are mastering your mixes as well. And just to show you how you can use this, I put a reference track for this mix that is the same track of the same band. And I put it in the arrangement, and I make a... Hoppala, come on, sorry. I put it via drag and drop into the list. So, and this is this one here now, and it's important that it's if you want to listen to the reference, that it's not going into the same master out and the same master plugins. So I send it to a stereo out 2 in the mixer. So there's no limiter or EQ, whatever, on this track. So on this, it sounds like this. It doesn't sound at all because it's not connected. Sorry. Another interface than in my control room. So, and I also have forgotten to match the volume. Yeah, there's 6 dB. Okay, so this one should be 6 dB quieter. Okay, this is a same song, another song from the same album, from the same band. If you call me, I'll be there. You and me right on right. When your face is all I seem to follow. Right on right. I'll be there. No man on right. What the world is. You can tell it's the same singer, it's the same album sound, but there are differences, of course. And it's in another key. The singer's singing in another range. There are other sounds in the playback, but still, it has to match. That part of the song we are mixing actually, and it's really for this one I'm using often only the peak lines because it's only for a small part and it's only the chorus part, and I check out if it fits and if it has also the same loudness, and that is also something you can do. You can measure the loudness of a clip, and this one is the last chorus of the reference mix and is a loudness of minus 9.1 LUFS, and that is something I have to reach with my actual mix right now as well. So it can also be a tool for your metering and for your compressing and limiting of mixes in order to get the same loudness that you're going for or that your reference mix has. And yeah, it can help you to understand that as well. So that much for this mix, and mix is another keyword I want to remind you of the Xmas Mix contest that's still running in January on HOFA it's HOFA-contest.com, and you can win great prizes there with your mix or remix of the contest song. We have great prizes from our partners, and the overall worth of the prizes is more than 25,000 euros. So it's really worth entering the contest and having some chances for the win and a good time with the contest song. That much about this. I want to go and move on to the last project I prepared for this workshop, and this one is about using mid and side information for your mix. So let me open it. Come on, here it is. So this is just a guitar. It's a mono track, as you can see. And as we learned before, the frequency goniometer and the goniometer shows you that there is no stereo information at all. There are no side signals. There's only the mid signal in this track. So I prepared a effect setup that is making the guitar really wide, and I'm going really over the top, and it's much too much, but just to show you. And here in my listening position in the sweet spot in this control room, it really sounds awful. It sounds like it's everywhere, but not in the speakers. It's way too wide, and there's no more mono compatibility. As you can see when you switch to, or you can hear when you switch to mono. Just let me show you. Stereo and mono. And the mono signal really falls together, and it gets much quieter, and it's not a good idea to make signals so wide. And the goniometer is like a great tool to understand that and to show you there's too much energy in the negative range, in the side range. And you can see this in the frequency goniometer too. It's getting red all over the place, and that's not a good sign. And for you to understand this even more, you can also use not just the mid signal for the analysis of the frequencies, but you can also use the the side signal for analysis, left and right channel, but you can also combine those, mid and side and left and right. Just let me show you what you will see when you switch to mid and side in the display. The white one is a mid signal, and the orange one is a side signal. And this shows you clearly that the side signal is like almost 8 or 9 dB louder than the mid signal. And that is what is shown here in this goniometer. This is the level of the mid signal, and this here in the goniometer going downwards is the level of the side signal. And this display shows you that even clearer. And when you just when you switch to mono, all the side information is getting lost because they are really they are out of phase, and that is why turning a stereo mix into a overly wide and stereo and out of phase mix is not a good idea. And a analyzer and a goniometer and a frequency goniometer can help you to have an understanding of that, because I can hear it clearly now here with my speakers. But if you're listening to that on headphone, it almost sounds okay. And if you're not used to to look out for that, you can even think, "Whoa, it's a nice and wide sound. I love it." But you don't understand that it's out of phase and that it's too wide. So always look on the analyzer, but also look on the frequency goniometer and the normal goniometer too. It gives you an overall insight of what's happening in your mix, not only in the frequencies, but in the stereo field as well. So, and this brings me to the end, and this is a last chance to remind you of the flash sale we have for the IQ series analyzer. Just go to hofa-plugins.com, go to the analyzer website, and when ordering, type in analyzer 20 and buy it with a 20% discount. So that's it for me from this about this topic, and thank you for your questions and for being with me. And if you are interested in more information about HOFA-College or about audio engineering, just visit our website and learn more about our audio diploma and the bachelor and the other topics there. That's it from me. Have a nice evening and bye-bye.